Integral of 4x squared times natural log of x. Okay, so my first feelings here is integration by parts, or as French say, integration par partie. And the reason I see that is whenever you see, so you have two things here, and my eye is drawn to this x squared, and it's like, all right, if I take the derivative of x squared enough times, it will disappear. And that's a key sign that integration by parts will work. And so I go like, all right, start with integration by parts. I know integration by parts is really just the product rule in reverse. This is the way so I don't have to memorize the integration by parts formula. So I rearrange this into uv prime equals, wait a sec, uv quantity prime minus u prime v, product rule. Integrate everything, integral u dv equals, this will be the integral of the derivative, which will be just the normal function, so uv, minus integral v du. And this is the formula for integration by parts. You'll see abbreviated IBP. I do it, say IPP, because that's the French way, and I know, I like it better. No actual logical reason why, just my feels. All right, so now we're going to set it up as u equals v prime equals, and the mnemonic that a lot of people use is I late. So this is inverse trigonometric, this is log, so natural log, this is algebraic, something like x squared, this is trigonometric, sine, cosine, tangent, secant, cotangent, and this is exponential. The idea is exponentials never go away, so you really don't want to use them as the v prime, or as u, if you can help it. And this is to help you choose u's. Some people say liadi, but that's just such a pain to memorize, just the switch in the L and the I. I like I late better. And pretty much you're going to, that big idea is you do inverse trigonometric and log before you do algebraic. And that's where it's going to come in 90% of the time. And that's where it comes in here. So we see log, so that's going to be our u. And this is just a rule of thumb. 90% correct, which is hopefully good enough. And if you do something and it doesn't work, you just go back and redo it some other way. So du equals 1 over x dx. V prime equals 4x, I can write that a little bit higher, 4x squared. Therefore, we have 4x cubed, 2 plus 1, over 3. And this will put a little dx down there just so we know that it's the derivative. All right, now I put it into the formula, and I'm going to do orange. So we know that integral u dv, which is what we're trying to solve for right here, will be u times v, so natural log of x times 4x cubed over 3 minus integral of v, this one, 4x cubed over 3 times du, which is 1 over x dx. Now this 1 over x becomes handy then, because that then cancels with one of those. And we have, natural log, I don't need to use absolute value signs because I didn't get that natural log through integration. If you get the natural log through integration, then you have to do absolute value signs. But since we were given the natural log with parentheses, we can just keep the parentheses there. I know, it's a small nuance, you probably don't care. You should, just because it's correct. So if you get a natural log through integrating, put the absolute value sign just to make sure you're not trying to take the natural log of a negative number. So it's one of those like divide by 0 type things. The universe explodes and everyone is unhappy. So we have 4x squared, which becomes 4x cubed divided by 3. We'll put in another 3 for that 3 there. And then I'll rewrite this one more time. So we have 4x cubed over 3 times natural log of x minus 4x cubed. We could factor it out, I'm not going to, over 9 plus a constant c. And that'll be our answer. So to backtrack here, what we saw was we had two, I guess, function-looking things. One of them, if we took the derivative enough times, it would disappear. So we're like, all right, let's try integration by parts. We came up with a formula, reverse engineering the product rule, and from there we've just plugged things in, and we got an answer and it worked. And so then we quit working. So hope that helped, and I'll see you next time.